So for number 4, where it says, what's the sum of the sequence? First thing we need to decide is, what type of sequence is this? We need to know if it's arithmetic or if it's geometric. We've been through this. We also need to ask ourselves another question, and the next one's going to be fairly obvious. We need to ask if it's finite or infinite. Okay, knowing that it says the sum of this sequence, but if it's a sum, it really turns it into a series. It's kind of a terminology thing, so let's erase some commas here, and let's put some plus signs. We're really adding these. There we go, we're going to add that. So let's go here first. Is it finite or infinite? Waiting. Kidding. I hope you said infinite. It's infinite because it never ends. It never gives us a stopping point. Because it's infinite, I'll go ahead and tell you, it's going to be geometric. You cannot add infinite arithmetic series, and the reason you can is you'd end up with an answer of infinity or negative infinity. It doesn't really work too well. So knowing that it's infinite, that automatically kicks it over to geometric, but I want to go somewhere for just a minute to refresh your memory in case you didn't make this connection. Let's pretend for a second that it's arithmetic, and we're going to tinker with this just to prove a point. If it's arithmetic, then I should be able to subtract this minus this, 0.1 minus 1, and I will get some number, which in this case is negative 0.9. Now if I subtract this one minus this one, 0.01 minus 0.1, I should get the same thing, but I don't. So because of that, it's not arithmetic. Geometric, on the other hand, if I divide, it should work. So 0.1 divided by 1 is 0.1. 0.01 divided by 0.1 is 0.1. And because of the consistency from one to the other, we know that the common ratio is, boy, I hope it's obvious, it's 0.1. Knowing that my common ratio is 0.1, that's going to help me. So we know the common ratio now, and we know the 0th term or the first term. Okay, and this may have been said before, but when I taught it as if it was the 0th term for reasons that really help people understand the formulas. On the exam, the formulas they give you are going to start with the first term. So for the sake of being consistent with what they do, we're going to pretend like this is actually a sub 1, whereas in the past we called it a sub 0. Again, just to refresh your memory, we would say that this was a sub 0 and this is a sub 1. And although I prefer this, and it really helps people understand the formulas better, we're going to go consistently with what they do. So that's a 1, a 2, a 3, a 4, a 5. Here we go. There it is. So a sub 1 is 1. Now, we can go recursive, we can go explicit. Hopefully these words are sounding familiar to you. But essentially, we need to add all this stuff together. And we can type it in our calculator up to a point. But because it's infinite, we can only type so much. So it's kind of futile to try to type all that in the calculator. Instead, we're going to use the formula. And the formula is this. The sum of an infinite series, infinite geometric series, is going to be the first term, which we formerly called the 0th term, divided by 1 minus r, and if you're going all calculator on it, which won't be completely necessary in this case, you'll put that in parentheses. So the first term is 1, and again, these formulas are on the formula sheet. 1 minus 0.1. I'm going to do this without a calculator because when you get your answer, it's going to still be slightly difficult to translate your answer on the calculator into one of the answer choices. So what we really have is 1 divided by 0.9. Okay, I'm going to get crazy for just a second here. I don't like that decimal on the bottom. I'm going to do something perfectly legal. You did it back in the day. Let's move the decimal over one place. On the bottom and on the top. That really makes it 10 over 9. 1 over 0.9 is the same thing as 10 over 9. If you notice, all of the answer choices are mixed numbers. This means it is 1 and something. 9 goes into 10 one time with 1 left over out of 9. That's a little bit of 3rd, 4th, 5th grade math right there. 9 goes into 10 once with 1 left over. Just because I feel like it, I'm going to go here. 9 goes into 10 once. Put the 9, subtract, it's 1. 1 and 1/9. 1 and 1/9. There you go.